Hello, lovelies. I'm Miss Physics. Welcome to part 2 of our question about magnetic fields and moving charges. Let's continue with the question. The whole voltage VH developed across the foil in P is given by the expression VH equals PI over NTQ, where I is the current in the foil. You have to state the meaning of the quantity N. N, I'm sure you remember from last year, N is called the number density of charge carriers. Number density of charge carriers. Last year, we defined number density as the number of free electrons per unit volume, and we used the number density to derive an equation for current. The next question, it asks you to identify the distance t using the letters on figure 9.1. If you don't remember, t is the thickness of the foil. So if we go back to figure 9.1, we see that thickness t is given by the distance PV or SW or QT. You can write any of these distances. I am going to write PV. So PV is the thickness of the slice. And the last question, it says, suggest why in practice hole probes are usually made using a semiconductor material rather than a metal. Now for a semiconductor, N, the number density, is very small, so VH, the whole voltage, is much larger. So for semiconductors, N is much smaller. So VH is larger. Remember, in this equation for whole voltage, if we want whole voltage to be a large number, we need the denominator of this equation, NTQ, to be as small as possible. And how can we do that? Is by having a small n, small number density, and a semiconductor has a small number density. And also T, the thickness of the slice, should be as small as possible. If the denominator of this equation, N, T, and Q, is a small number, then VH, the value for the whole voltage, is much larger, and you can actually get a measurable value for whole voltage. I hope all this, it makes sense, and I'm waiting for questions from you. Thank you for watching.